Hey class, let's review for our 10.1 and 10.2 quiz. I do plan to spend a little time in class reviewing, but we certainly won't be able to do it all. So if you want to do a little review on your own, here you go. So let's start by writing a rule for the nth term of this arithmetic sequence. Here's the general formula. A sub n equals dn plus a sub 0, where d is the common difference, is what it's changing by, and a sub 0 is the term before the first term. So first you have to identify the common difference, and so this is changing by adding 3 each time. So that means our d is 3. And then our a sub 0 term is the term before the first term. So if our first term, a sub 1, is 1, then the term before that, you would go backwards and you'd subtract 3 and get negative 2. So a sub 0 is negative 2. Then the rule would be a sub n equals 3n minus 2, or plus negative 2. Then a12, it should be a with a little subscript 12, means to find the 12th term. And you can find that by plugging in 12 into the equation for n. So this would be 36 minus 3, which is 33. Write the next term in the geometric sequence and then find a sub 6. So let's see. Negative 4 times negative 4 is 16. 16 times negative 4 is 64. 64 times negative 4 is 256. And so it looks like our R value is negative 4. I'm going to write the rule here to find our next term. So a sub n is a sub 1 represents our first term. Our first term is negative 4. I suppose I don't need parentheses there. And then r is negative 4 as well. And then it's always to the n minus 1 power. N minus 1 is important because then if we find the first term, you end up with 0 power. So you get the base to the 0 is anything to the 0 power is 1. So the first term is always identified by the a sub 1 right here. So that's why we do the n minus 1 power. If I want to find the sixth term, then a sub 6, I need to plug in 6. So it'd be to the 5th power, negative 4 times negative 4 to the 5th. Or since you have negative 4 to the 1st times negative 4 to the 5th, you could just take negative 4 to the 6th and get the answer. But negative 4 times negative 4 to the 5th power, 4,096, would be the 6th term. Okay, to find the sum, you need a sum formula. This is an arithmetic series, and so this is the formula that we need. For a sum of a geometric series, you need this formula. So geometric series always deals with the R. A sequence or series has the R in it. And then arithmetic, there is no R. So the n represents the number of terms that you're finding. So I want the sum of the first 14 terms. So n will be 14. A sub 1 is the first term, so 9. And then in the formula, you have an a sub n. That represents the last term, essentially. And since I'm finding the sum of the 14 terms, I'm going to want the 14th term in there. So you're going to end up taking 14 times the first term plus the 14th term and then dividing it by 2. So I know the first term is 9, but I don't know the 14th term. You could count out to the 14th term, or you can use the formula if you write the rule to help you find the 14th term. So that's usually what I do first, is write the rule. So dn plus a sub 0. So let's see, what are we adding here? 9 plus 4, 13 plus 4, so it looks like 4 for D. Then 9 minus 4 to go back to a sub 0 would be 5. So our rule would be 4n plus 5. And then that way I can find the 14th term by just plugging in 14 for n. 14, 28, 28 and 28 be 56. Plus 5 would be 61. I'm just going to check my math. Okay, 61. So then now I can plug it into my equation over here. So it'd be 14. The first term again was 9 plus the 14th term, which was 61, divided by 2. Then I'm going to add on top first. 9 plus 61 is 70. 70 divided by 2 is 35. And then 14 times 35 to get my final answer is 490. That would be the sum of the first 14 terms of that arithmetic sequence or series. Okay, let's do the same thing, but this time it's the sum of a geometric series for the first 10 terms. So similarly, the n represents the number of terms that you're adding up. So we're going to find s sub 10. Except for this time, it's the a sub 1 is the first term, which is 1. And then it's times 1 minus r to the n over 1 minus r. Here it looks like we're multiplying by 4. 4 times 1 is 4, or 1 times 4 is 4. 4 times 4 is 16, etc. So r is 4. So plugging in will be 1 times 1 minus 4 to the 10th power over 1 minus 4. Now I would type this in as 1 parenthesis 1 minus 4 to the 10th, and then divided by 1 minus 4 here is negative 3. So I broke apart the fraction here and did the top divided by the bottom, and I did simplify the bottom first. Since the r is positive, you don't need a second set of parentheses inside these, because the calculator will know to take 4 to the 10th first and then 1 minus that. And then it'll work from left to right. 1 times this divided by negative 3. So 1 times 1 minus 4 to the 10th divided by, I'm going to put negative 3 in parentheses though. So 349,525. I highly recommend practicing using the calculator that you plan to use on the quiz to help make sure that you're getting the correct answers here. If you need to borrow, if you're doing this on Wednesday and you need to borrow a calculator, talk to Mr. Taber, or my calculators are in 1611. Write a rule for the nth term of this arithmetic sequence. So this one is giving me the d, which is the common difference, and it's telling me that the 8th term is 36. So this is similar to when we have a line and you're given the slope and a point, and then you need to solve for the y-intercept. Essentially, that's what we're doing. Our common difference is 4, and then we're given this ordered pair, essentially. The 8th term is 36. So when you plug in 8 for n, your answer, your a sub n, is 36. So I have my common formula here, my generic one, and I can plug in the 3 things that I know. I know that n is 8. I know that a sub n is 36. And then I know d is 4. And then those 3 things will help me find a sub 0. So I'm going to plug 36 in for a sub n, 4 for d, 8 for n, and then plus a sub 0, then solve. So 36 equals 4 times 8 is 32 plus a sub 0. It's plus a sub 0, so you need to subtract. And we get 4 equals a sub 0. So now I have d equals 4 and a sub 0 equals 4. That's a coincidence, so I can write my final answer as 4n plus 4. And that's called an explicit rule. I can use that rule to find any term in the sequence then. I could check my answer by plugging in 8 to make sure that my 8th term equals 36. Okay, this is the same idea, but this is a rule for the nth term of a geometric sequence. So this time I need the general formula a sub 1 times r to the n minus 1. I'm given r, so I need to figure out my first term. This is telling me my ninth term is 64. So you could count backwards by dividing by 2 and go back to the first term. Or you can solve it algebraically. Because again, if you know the ninth term is 64, then you know when you plug in 9 for n, your answers for a sub n is 64. And then r is 2. So you'd plug in the 2 for the r. You'd plug in the 9 in the n spot. And then you plug in the 64 for the answer. And then that would be able to get the a sub 1 isolated. You could solve. So 64 equals a sub 1 times r is 2 to the n minus 1, so 9 minus 1 power. So it'd be 64 equals a sub 1 times 2 to the 8th. Be 64 equals a sub 1 times 2 to the 8th power is 256. And then the one main difference here is since this is a sub 1 times 256 and not plus, in the last one it was plus, so we subtracted because that's our inverse operations. Here it's times, so we need to divide by 256. And we get 64 over 256. Now, I'm pretty sure 64 goes into 256. Let's see. 256 divided by 64 is 4. So 64 and 1 or 64 and 4 for that fraction. So you can reduce this to 1/4. Essentially, I'm just factoring out a 64 from each or dividing both the top and bottom by 64. So a sub 1 equals 1/4. And then r was 2. So my final answer would be a sub n equals 1/4 times 2 to the n minus 1. So that's my explicit rule. Again, I could check it by plugging in 9 because I know my ninth term is 64. So if I plug 9 into this, I should get out 64. Okay, just a quick refresher, which rule is used for what. So these will be at the top of your quiz and your test, and you need to know which is which. So this one is an explicit rule for geometric. A sub 1 times r to the n minus 1. This one is the explicit rule for arithmetic. So an equals dn plus a sub 0. On Friday, you're going to learn about recursive rules, so that's why I'm using that term explicit, because there will be a difference. And then these two kind of go together here because this one is the sum of the arithmetic series. And this one has the r in it, so this one is the sum of a geometric series. So just going through those. Let's see what else I got here. And these just start to repeat again. Let's see. I'm going to say that, let's see if we can solve this one. If a sub 1 is 21 and a sub 5 is 45, given that information, can we write a rule? So let's practice one of those substitution problems because the rest of the problems seem to be kind of repeats on here. So if you're given two of the terms and I tell you it's arithmetic, I want you to set up a system of equations using the n and a sub n. 5 and 45 would be n and a sub n, and then using substitution to solve. So you're going to plug it into a sub n equals dn plus a sub 0 you know the n and the a sub n. So the first equation is going to be 21 equals 1d plus a sub 0. The second equation over here is going to be 45 equals 5d plus a sub 0. I solve the left side for a sub 0. Since it's a sub 0 plus 1d, I'm going to subtract 1d from both sides. Now these are not like terms here, so you can't put them together. So it's just 21 minus 1d equals a sub 0. Then I'm going to take this 21 minus 1d and I'm going to plug it into this side for a sub 0. So I'm going to get 45 equals 5d plus 21 minus 1d. Then I'm going to combine like terms. So 45 equals 5d minus 1d is 4d plus 21. Finish solving for d. So plus 21, subtract 21 on both sides. I'm going to get 24 equals 4d. Divide by 4. I'm going to get d equals 6. Then plug that back in over here and you're going to get 21 minus 1 times 6. 21 minus 6 is 15. And that's going to be our, a sub 0 term, sorry. So then we could write our rule. It'd be a sub n equals 6n plus 15. So let's go back and check what we had here. It is plus 6, that works, and our a sub 0 term would be 15. So just practicing that substitution there. We could do it again too if you wanted. Let's see. 75 times 5 would be 375. So our first term is 3 and our fourth term is 375. So this is a geometric sequence this time. So we have the points 1, 3 and 4, 375. So you start it the same way except for that you plug into a sub 1 times r to the n minus 1. So this one would be 3 equals a sub 1 times, you know what, we're actually going to have to use the second term, otherwise it's not going to work. The second term is 15. Apologize. So this is going to be 15, and a sub n equals a sub 1 times r to the 2 minus 1 power, or 15 equals a sub 1 times r to the first. Over here, it's going to be 375 equals a sub 1 times r to the 4 minus 1 power. So 375 equals a sub 1 times r to the third. Solve this side for a sub 1, so divide both sides by r to the first using inverse operations. So if it's adding, you subtract. If it's multiplying, you divide to get a sub 1 by itself. So 15 divided by r1 equals a sub 1. Then we're going to take this and plug it back in for this a sub 1 right here. It's going to be 375 equals 15 times r to the first, all times r to the third. Now remember, r to the third is the same thing as r to the third over 1. Then r to the third divided by r to the first, 3 on top, 1 on bottom, reduces to r squared. So you get 375 equals 15 times r squared. This is times, so we're using division. 375 divided by 15 is going to be 25. Then take the square root, and we get r equals 5. Plug that back in over here, and you're going to get 15 over 5 to the first is going to be 3. That's going to be your a sub 1. So final answer would be 3 times 5 to the n minus 1 power. So just practicing that substitution as well. There's a few more problems if you want to practice another sum or finding given two terms, etc. Otherwise, we can save those for in class too. All right, hopefully this was a quick review, but it was helpful at least. Remember, the videos for all of the sections are posted for each notes section. Thanks for watching.